Hi, I'm Callie Collins, Chief Product Officer for Optimality, and today we're going to be talking about the calculations within the BPM domain, which is your activity domain in Optimality. We're going to start out with a bit of context here, and I'm going to do some slide reading, and then we're going to get more into the math. So you can fast forward past this part if you're already familiar with some of this context. Otherwise, it's good as an educational tool or just as a refresher. So our BPM, which is based on business process modeling, this is the glue, the logic, the brain that really makes Optimality work. By utilizing the standard business process model notation, which we've then evolved into a BPM Plus by adding scheduling and date planning, we're able to capture the actions and relationships for countless use cases in any industry. And we're able to use these to provide the users with optimized workflows to push the right data to the right people at the right time to allow you to make optimal decisions. Getting into some of the terminology we'll be using, an activity is anything that requires action. It could be pouring a concrete foundation, developing software code, reviewing an engineering document, or developing a department resource plan for next year. It's something that has duration and typically would be completed by one or more people. A milestone activity is a target or a goal date for when a team or user should have a series of activities complete, and it has 0 duration. A relationship creates a constraint between activities and/or milestones. These relationships are used to show sequence relationships, such as one activity must finish before the next one can start, or a resource relationship. And this would show that maybe the same person, crew, team, computer, truck, or crane, or other type of resource is working on one activity, and it must complete that before it can move on to the next activity. An example of this would be 2 concrete foundations. They technically could be poured at the same time, but maybe the same crew with the same concrete truck must do one before they're doing the other. This ability to have 2 different types of relationships is something that is a future functionality of Optimality at the time I'm recording this. Right now, there's only one type of relationship, and they both work the same. You're not able to designate yet whether it's a sequence or resource, but they both cause a constraint between activities and milestones. The last one on here is associations. So an activity must be associated with an endeavor, and an endeavor is a grouping of activities that are done to accomplish a goal. Content could be associated with these activities. So you could upload a deliverable, a PDF, any type of item, and associate it with an activity. In addition, tasks should be associated with an activity. A task is just a small checklist type of item that doesn't necessarily need to be a card on your activity flow diagram, but rather is something that helps to contribute to the completion of an activity. Content and tasks obtain their relationships in logic and their connection to the endeavor through their associated activities. So there are multiple aspects to this BPM or this activity domain within Optimality, each one containing one or more screens that you're able to use. Primarily, you're able to create and edit activities. You're able to view the activity flow diagram, and that's going to be a relationship of lots of boxes, which are called cards, of each of the different activities and milestones, and the arrows created between them to show the relationships. We also have a list view for your activities, which also includes a Gantt chart. The scheduling, which includes all of this stuff that we're going to be talking about right now, as well as planning with calendars. We'll get into that in a different deep dive session, and commitment planning as well, which can be ran similar to sprint cycles if you're familiar with that. So as you can see, the BPM domain could really function as a complete software on its own. But the differentiator for Optimality is that we're building this on a node graph database. It is able to learn via artificial intelligence and machine learning, which we are now in development of that area. And additionally, by combining BPM with your content, tasks, notes, and in the future, you can add in your emails, chats, or any other means of communication, the BPM really knows what people are working on, what the status of that work is. Behind the scenes, the BPM is the end user's viewer or editor into that node graph database when you're referring to workflows, relationships, activities, that side. So when you're creating these activities, milestones, and relationships on the BPM domain, so on your activity flow diagram, they are creating those nodes and edges in the database. When we create actions for optimality to execute using an if this then that, that's also creating actionable steps within our database. So now let's jump more into CPM. CPM is the critical path methodology, and this is what the basis is for the calculations within optimality. CPM is the scheduling logic that's used in Primavera P6, Microsoft Project, which are two of the most popular scheduling softwares. What we will be doing is integrating a simple CPM, and it's going to be based on the following factors. The first is relationships. The most basic relationship is a finish start relationship in CPM, and that's the one that we'll be using in optimality. This is stating that the preceding or predecessor activity must finish or be completed before the successor activity can start. Users can set for each activity the working days, hours, and holidays or other exception days. So those calendars can be customized for each organization, for each endeavor, and those are what's assigned to each of the different activities. For simplicity, you can have the same calendar tagged to every activity within your activity flow diagram for an endeavor. Or if you have people working across time zones or working different shifts, you can start getting pretty smart with it and assigning those to different activities. An example here, if an activity is set to finish on January 16th, the next activity can start on January 17th. So that would be a finish start relationship. One finishes one day and the next can start the morning of the next day. When a predecessor is finished, the successor is now constraint free and it can start. That doesn't necessarily mean it automatically starts, just that it can. So once you complete one activity, the next activity down the line is able to be started. It is now considered constraint free. For durations, those are able to be input as hours or as days, and they will be converted between the two based on the calendar that's selected for that activity. So if you select a calendar with an 8-hour workday and the user inputs that it's 2 days, it will calculate that that's 16 work hours. If the user inputs 24 hours, it will back calculate that to 3 days. So the example here, if the start date is January 15th and the duration is set to 2 days, the projected finish date is January 16th. So it would start the morning of the 15th and end the afternoon of the 16th if you're working a standard type of schedule. So now let's start getting into some of the calculations here. We're going to start pretty high level and simple, and we will dive into some more nuances of really how you can make this work for your different use cases. So let's start with start dates. If an activity is constraint free, that means it has no unfinished activities before it, or just no activities at all before it, it is assumed that it can start today. We do that because we cannot start an activity in the past, and this helps to promote people to maintain optimality on a regular basis and make sure that you're updating your statuses. Now you can put in an actual start date in the past if needed, but we don't project that it's going to start in the past as a plan. So here's a very simple example. In these examples, we're going to assume that today is June 1st. And when you see the dates on here, that is month and then day. In the actual system, it's written as day/month with 3 letters, just to make sure we're clear on whether that is June 1st or if that was January 6th, depending on where you're located in the world. For the examples in this slide deck, that is June 1st, month, day. So if the activity isn't started today, when the user logs in tomorrow, everything's going to be updated to June 2nd. So it automatically maintains that the planned start date for that first activity is today. So we call this one here a forward pass. So you see the first activity is 2 days long. It starts the morning of the first, ends afternoon of the second, and then activity 2 is able to start the morning of the third. It ends the afternoon of the third because it's a 1-day duration. Activity 3 is 3 days, so it starts that next day on the 4th, and it can finish on the 6th. The early start dates and finish dates are based on today's date, the logic between the activities, the duration of each activity, and the calendar associated with each activity. What this is doing is it's giving us our early start and also our projected start if the activity is starting as soon as possible, but we'll get on more on that later. It also gives us the early finish dates. So this would be the earliest each activity can start and the early each activity can finish if the projected or planned duration ends up matching the actual duration. So you can see here with the flow of the arrows, the early finish date of the first activity drives the early start date of the second activity and so on. So now let's look at some projected or the specified finish dates. So in P6 and Microsoft Project, the user can set a finish date of their overall project. In Optimality, we set the finish dates based on your milestones. What this does is it allows you to have multiple finish dates throughout. So when a user creates a milestone activity, they are manually inputting in a projected finish date. So when you create a milestone activity, you have a field to input your target date, and you input that date that you hope that milestone finishes, or when you're targeting for that milestone to finish. A milestone has 0 duration because it's not an activity that someone's doing, but rather a goal that someone is reaching. Note that predecessors of milestones use that milestone's target date. So here we're going to watch the flow again. Activity 1 is 2 days. Now we have the early start for activity 2. Now we're going into a milestone. The previous activity's early finish was on the 5th. The target for the milestone is on the 8th. Now for activity 3, which is a predecessor of that, it's driven by that target date of the milestone, and it can start on the 8th. And because it's a 1-day activity, it's assumed to also finish on the 8th. So now that we have a target finish date, this milestone here, we're going to calculate the backward pass. And this is pretty standard. This is standard terminology for CPM methodology. So now we're going to calculate these late dates. So this is the latest that each activity can start and still meet the milestone. So now we're going to go backwards from this 6/8 date on the milestone. And that is the latest that activity 2 can finish and still meet the target date of the milestone. We subtract 3 days from it, so it can start on the 6th, and therefore activity 1 should finish on the 5th, and it can start on the 4th. So as you can see, these 5 days worth of activities in activity 1 and 2, they can start as late as the 4th, and they're still able to finish by the 8th, which is your milestone's target date. So we now have late start and finish dates. So that backward pass going from the milestone is called the backward path. The buffer is simply the difference between your early start and late start for each activity. And the reason we calculate this is it shows you how much buffer you have or how much variance you have. You will also see in traditional CPM, they call that float, or they may call it slack, an example of Microsoft Project. There's a lot of different words for this date, but really what it is it shows how many days you can be late on that activity and still be able to meet your target. So now let's start adding in some actual dates. When adding in the actual dates, the early and late start and finish are no longer necessarily applicable. So in this first activity, let's assume that activity 1 actually started on June 2nd. So we'll remember from the previous activity, it was planned to start on the 1st, but let's say we actually started it on the 2nd. So now you can see the dates have recalculated. The earliest finish date would be the 3rd now, but the late finish date did not change. For activity 2, it can now start on the 4th. It can no longer start on the 3rd, and it can finish on the 6th. So now we have a buffer of 2 days instead of 3 days, which we had on the previous slide. We'll also notice that we are starting to add in a projected date on the milestone. So that is similar to an early date for the previous activities. So that's showing what is the soonest that milestone could be completed based on all of its predecessors also being complete. If we followed the early start and early finish dates, then that would be projected to be completed on the 6th. So that milestone would have a buffer of 2 days also. So now going into down here, let's say activity 1 has now finished. So we now have an actual start and an actual finish date, and the buffer goes to 0 for activity 1. Now for activity 2, it is now constraint free and it can start. So it is projected to start on the 5th. We'd also would assume that today's date is probably now either the 4th, and we just mark this as complete, or today's date is the 5th, as of this example here. And now we can start it on the 5th, and it can go until the 7th. We've now eaten up one more day of buffer. So previously, activity 1 was supposed to only be 2 days of duration, but it took us 3 days. So now you can see our buffer is starting to reduce on our activity number 2. We started with 3 days, then we were down to 2 days because we started a day late on activity 1. Now we're only down to 1 day because we took an extra day to do activity 1. So we're starting to get a little bit closer to potentially running late. Now that activity 1's duration is actual, we can see that they are down to that 1 day of buffer. This does get more complicated when you have multiple concurrent paths of activities. You could have multiple activities going into activity 2. You could have activity 2 have multiple activities after it. You could have activity 1, 2, and then the milestone. You could also have activity 1, another milestone or activity down here, and then back up into the milestone. So you can see it starts to get a little bit more complicated, especially when you start adding in weekends or holidays and you have time where you're not doing full work days, but the calculations are still the same if you go back to the principles of what we're looking at here. So now let's look at some of the constraints you're able to add. The main one that we have integrated into optimality is start no earlier than. So this is similar to a lag date, which you would see in some other types of scheduling softwares and in standard CPM. But because we're doing kind of a CPM light, we will not have that. So what we're able to do is tag a start no earlier than date and input a date. So what that would do is on an activity, you can tag that, check that box and input a date. And what that will drive is that your early start date cannot be any earlier than that date. You could use this, for example, if you know that your material won't be delivered until a certain date, or if a crew won't be available until a certain date. It's also a way to assign an external constraint to an activity. In the activity flow diagram, these do have an icon that will be highlighted and show up on the card so that you can quickly see which activities have this constraint tagged to them. The next thing that we'll look at is start as soon as possible or start as late as possible. This section does not change the calculations. Rather, it's used for the visualizations and commitment planning. And now we're going to start getting into that on the next slide. So everything else prior to this is pretty standard CPM methodology. This is where we start adding in some of the nuances that we have in optimality. So in addition to the early and late start and finish dates, we're now also going to add in a projected start and finish date to our activities and milestones. We described projected dates for milestones on the previous slide, and so now we're going to show what they look like for activities as well. So the first thing is if you have a start as soon as possible, the methodology there is that the activity is projected to start as soon as it can. So this is already the same as our early starts that we calculated earlier. But we can now also toggle if the activity should start as late as possible. So this is going to show that your projected start should be how late can this activity start without delaying the milestone. And so initially you may think that sounds like it would be the late start and finish dates, but not necessarily. So we're going to take a look at that in this example here. So if the schedule is already behind or it's on target, so if you have a negative buffer because you were supposed to start that activity in the past, you're already running late and you're probably not going to meet your milestone target date unless you make some changes. Or if you are directly on target to meet that, that milestone date, so your buffer is at 0, it doesn't matter whether you're as soon as possible, as late as possible. Your projected start and finish date will be the same as your early start and finish date. However, where this starts to add some value is if you are ahead of schedule and you have positive buffer. So this is when the projected start and finish dates start to change. So instead of looking at the start and finish date of the predecessor, which we saw previously, so that's how the early start does it, is that forward pass. It's now going to look at the successor and the, so the calculation is that the projected start is based on the successor's projected start minus the duration of the activity. So the early start and finish dates that we saw before, those are available as columns in the activity list view, but those are not going to show up in your activity cards and pop-ups. Instead, the early dates are now replaced by the projected dates, so that way it can take as soon as possible and as late as possible into account. If you don't use this toggle and you keep everything as soon as possible, as we showed, the early start and finish dates will match your projected start and finish dates. There won't be a difference. They only start to change if you're using as late as possible as well. So this activity here, the first one, is as soon as possible. And so we now have the projected start date, which matches the early start date. You have your late start dates, and your buffer is 3 days. This second activity is as late as possible. So what it's going to do to get its projected start date is it's going to look at the target date of the milestone, which is the 8th, and subtract 3 days off of it. So in order to complete the activity by the 8th, and it doesn't matter on a milestone if it's the start or the finish of that day, as long as it can complete it on that day. So your projected finish here is going to be on the 8th, and your projected start is on the 6th. So in this example, the late start and the projected start do match, but that's not necessarily always the case, especially if you have multiple predecessors and successors. We do still carry this one out here as an example. This one is as soon as possible, and it's after the milestone. However, it doesn't really matter if activity 3 was as soon as possible or as late as possible, because there is no milestone out here allowing you to calculate a late start and late finish. There's also no milestone or any other activity out here to do as as late as possible to and pull the dates from it. It just stays as it is. So this one's projected start date still just matches the early start date. The next thing you'll see here, the buffer is still calculated as the difference between the early start and the late start, or the actual start and the late start if you've started it as well. So the buffer will be moved down to the 3 days. It still remains at that, even on this as late as possible. This is the reason why we retain the early start dates in the background of the system, is so that you still have that buffer calculation. For milestones, the buffer is the difference between the target and the projected date. And the reason for that is because the projected date of a milestone is based on the early finish of the predecessors, not based on the projected finish of the predecessors. So now let's step it up again and take a look here with multiple predecessor and successor example. The same logic we had before still works as long as you understand the logic, even when there are multiple predecessors and successors. So for this one, we have as soon as possible activity 1, activity 4 are both going into as soon as possible activity 2. Because we understood previously, an activity cannot start until any of its predecessors are completed so that it's constraint-free. This activity down here is 3 days long, and its projected finish is not until the 3rd. Its early finish is not until the 3rd. This one up here is the 2nd. So the later of the two dates is this one here. It's the 3rd. This is the one that's going to drive that calculation for activity 2. So activity 2 now cannot start until the 4th because both activities 1 and 4 must be completed. It's also good to note on here that now this buffer has reduced down to 2 days. The milestone is at 2 days as well. And you're also down here at 2 days for this activity. But this one up here has 3 days of buffer because it does have a shorter duration. So this one here would be able to start a little bit later if it needed to. If this activity were to change to as late as possible on activity 1, it would show it completing 1 day later. It would show it completing right before this predecessor would start. So that's another activity or example of an as late as possible, where this activity would pull from the projected start date of this previous one here. That's also a good example where the late start is not does not align with the projected start if you were to do that on that one. The next one down here, this is now an as late as possible example. So the early start here, at this as late as possible activity number 2, the early start changes, but the projected start stays the same because it's as late as possible. So on this one here, because it's as soon as possible, it's pulling the projected start from its predecessors and its early start from its predecessors. It's pulling its late start from the milestone's target. That's your backward pass. Down here, because it's as late as possible, it is pulling its early start from the predecessors, but is now pulling its projected start from its successor, the milestone down here. The next example we're going to look at is what do you do when you are behind schedule? This does have a few nuances that get changed on it, but in general, the strategy that we're looking at does still stay aligned. So on this one, the example of what I changed was I moved the milestone up by 4 days. So now your target for the milestone is on the 4th. The day today is June 1st, and we have 5 days worth of activities to complete between now and the 4th. So you can see we just don't have time to be able to complete all those activities. Because of that, the projected date of when we actually will complete these 5 days worth of activities is on the 6th. And therefore our milestones buffer is negative 2 days. You still do this backward pass with the targets here. And now your late finish date and late start date, once you carry over to here, is in the past. It's showing we should have started yesterday for activity 1. We should have started 2 days ago for the other activity here. There's also the late as possible example down here. So for this one, previously, if you were as late as possible, or if you were ahead of schedule, you were pulling from the target date for your projected. This is where it changes around now. So now if you are behind, you are pulling from the projected date. So that's a difference in the calculation on your milestone. The main reason for a lot of this strategy is when you are looking at when do we have to start activities based on the projected date, you want to make sure they're all sequential. If we don't do that, your milestone may switch places with one of your others if you're looking at projected dates, and we don't want that. Okay. The next thing that we're going to look at is time zones. So users are able to assign time zones and calendars to each activity. Your calendar includes the time zone. This is particularly helpful for teams that work globally. If all the activities in Endeavor are on a single time zone, however, this really isn't necessary. but it is helpful if you do have that example. So the example I'm going to show here is that activity 1 finishes on June 2nd at 5 p.m., and this is in Indochina time. 5 p.m. in Indochina time, which is in Vietnam as well as several other countries, is the equivalent to 5 a.m. that morning of Central Time, which is Houston as well as several other places. Houston is where I'm located. So because it is tagged to Central Time, technically that next activity can start only 3 hours later. It doesn't necessarily start the next calendar day. So let's run through that one again. So activity 1 started on the 1st at 8 a.m. Indochina time and finishes at 5 p.m. on the 2nd Indochina time because it is 2-day activity. The second at 5 p.m. Indochina time is equivalent to 5 a.m. that morning in Central Time. Therefore, the X activity, because it is a Central Time activity, its next start date its day starts at 8 a.m. on the 2nd. So it's not going a full 24 hours later. Technically, this activity is only starting 3 hours later than the previous activity finishing. And so you can see by tagging it this way, if you are working in multiple time zones, you can very much expedite the duration of when things are happening. So there's an example of that. Also note that the activity and milestone pop-ups show time. So if you look at the details of an activity or a milestone, you will see the time in there. But the card that's on the flow diagram just shows the dates. The dates and the times that you see should be based on the user's default time zone, and that is set by looking at the default calendar on their resource admin panel settings. So every user in the system can have their settings adjusted, and that's where it's looking at that from. So if the user is located in Central Time, then the dates that are shown on the activity flow diagram for activity 1 up here will be the 31st through the 2nd. Activity 2 will be the 2nd through the 4th. And now the last section that we'll be looking at is what to do for time calculations and partial days. So we are also adding in the ability to be able to tag the start and finish time for each day when you're creating your calendars. So for this example, activity 1 and activity 2 are both tagged to calendars that work from 8 a.m. to 4 p.m. Monday through Friday. So you can see here for activity 1, and we just showed a start no earlier than date here for fun. It's 2 hours, or it starts on November 18th. It is 2 days long. So it starts at 8 a.m. on the 18th, and it's planned to finish at 4 p.m. on the 19th. Activity 2 here, therefore, can be planned to start at the beginning of their workday on the next day on November 20th, and it is able to plan to finish at 4 p.m. on a couple days later on the 22nd because it's a 3-day activity. So now let's assume that first activity is a partial day. So our calendars are going to follow this rule. As long as the crew assigned to the successor activity, so the calendar assigned to that successor activity here, the next activity in line, can work at least half a day according to their calendar, they will start as soon as the predecessor activity finishes. So in this example, this one's only a 1.5 day long activity. They started at 8 a.m. on November 18th, and they're planned to finish at noon on the 19th. Because this next crew is able to work a half a day, so 4 hours, which is their 8-hour day divided by 2, so 4 hours, they are able to get at least a 4-hour shift in if they start right at noon on November 19th. That means this one is now planned to start at noon on November 19th and finish on the 22nd at noon as well, 3 days later. If this activity was 10 hours and it was scheduled to finish at 10 a.m., this one would still start at 10 a.m. because they could work at least a full day or at least a half a day. If this activity here was not scheduled to finish until 1 p.m., they would not be able to get in half a day, and it would default to start at the beginning of their workday on the 20th, which is the same as what it did up here. You can also note if the crew calendar for activity 2 was scheduled 10-hour days, but their day didn't finish until 5 p.m., they would still be able to start at noon on the 19th. Also note that if the user has a partial day activity like you see here, but you want the successor to start at the beginning of the next full day, you're able to override that logic by adding in a half-day buffer activity, or you can add a start no earlier than constraint to activity 2. In the future, we may put in a setting where the user can toggle whether that particular crew calendar always starts at the beginning of the day, or if this activity here needs to start at the beginning of a day, but that's something that we will look at in the future. So thank you for listening to this presentation, and please post any comments or questions that you may have.